Right, so in this section, we're going to talk about measures of center, variation, position, and a lot of this is stuff that you've seen before, right? So these are called measures of center because when you have like a list of data, right, and when you look at like the average or the median, you look at basically what's happening at the center of that data. Okay, the most common examples are so mean. That's another way to say average, right? So it's like hey, what's the average of these scores and so on. But we don't use the word average in statistics. We always use the word mean. And it's the sum of the values divided by the total values, right? You guys know how to take average. Okay, median is the value at the exact center of the data. So if you take all the numbers, right, the one that's exactly at the middle, or if there isn't one middle value, it's the mean of the two middle values. But the most important thing here is that the data has to be arranged in numerical order. So you have to go either from increasing to decreasing or decreasing to increasing. All right, so like low to high or high to low. The mode is the value or values that happen most often. A data can have no mode, like if there are no, like if I looked at all of your grades, let's say for this last quiz, if each of you got a different score, then there is no mode, right? If let's say, 3 people got like a 13 out of 15, that's a mode, right? The number that occurred most frequently. So there could be no mode, one mode, or more than one mode. Okay, so here we go. The number of hits Marcus made for his team. We need to find the mean, median, and the mode. So for the mean, we're just going to add up all of them. 3 plus 6 plus 5 plus 2 plus 3 plus 7. And before you ask, okay, divided by how many of them are there? 6. And before you ask, yes, you can use your calculators. This is about 4.33. And we will have specified, the quiz will have specified, or the test, how many decimal places you need to go to. Okay, for the median, you first have to sort these in increasing order. I like increasing order. So start from the smallest one. That's a 2. Then we have 2 3s, a 5, a 6, and a 7. I like to cross them out as I go because it's easy to miss, right? And then afterwards, always count to make sure you got all of them. Okay, so is there a single middle value? No, because it's even. That means we take the average or the mean of these two, right? So 3 plus 5 over 2, 4. Okay. So for the mode, once you sort your data, it's also easier to see the mode. So just look at the string of numbers, and if there's a number that repeats, like the 3, that's your mode. So you say mode is 3. You don't say 1 because there is one mode. You say 3. It's the number that occurs most frequently. So how many, and if I ask you how many modes does this have, it has one mode. Okay? All right. So the thing about mean or averages, 2 very different data sets can have the same mean. Okay? So for example, if 5 people took a test and everybody got, like the people got 80, 81, 82, 83, 84, right? The mean here is an 82, okay? But also, if, a person got, like if 2 people got 60, right? And, one person got 82, and 2 people got, 22, so like 104. Do you see how very different those scores are, right? But they have the same mean. So the mean doesn't necessarily, tell us a lot about the data set. So for that, we can also talk about measures of spread or variation. Because look at this data set, it goes from 80 to 84. This one goes from 60 to 104, right? One is a lot more spread out than the other. So what kind of things measure spread or variation? One is range. And range, what is it, Clay? The difference between. Okay, range is the difference between. So you basically take the highest value minus the lowest value. What's the highest value here? 74, and the lowest is 21. So range 74 minus 21, 53. Okay, so this is the number of minutes that Sarah talked on the phone each day this week. Find the range. So, the range varied from 74 to 21. So it was 53 minutes. Yes?
When I'm sorting out the range and I kept forgetting to subtract, I always remember it because, if you were to draw, it's from the highest number.
So quartiles. Okay, so how many quarters in a dollar? 4, right? 4 quarters in a year and so on. So quartiles basically divide up the data into 4s, all right? They divide the data set into 4 groups, and of course it has to be arranged in ascending order. Each of the data groups contains 1/4 or 25% of the data, okay? So if I got, like your test scores, okay, these people were in the top 25%, middle 25%, and so on and so forth. So the median marks the second quartile, or Q2, and it separates it into 2, okay, like the median, right? The first or lower quartile is Q1. It's the median of the lower half. There is a third or upper quartile, Q3, the median of the upper half. We're going to do an example and you'll see it's pretty straightforward. Now, when the number of values is odd, the median is not included in either half of the data when calculating Q1 or Q3. So that's important. And then what's important is what we call a 5-number summary. This includes 3 quartiles, the minimum, and the maximum. So the 5-number summary is literally 5 numbers. Okay? All right. So let's go to the 5-number summary here. So basically what we need is the minimum, the maximum, Q1, Q2, Q3. So the first thing you want to do is make sure your data is sorted. Sometimes it will be, sometimes it won't be. Now, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Where is the median? 41 is the median. I call that Q2. Okay? So here, median is Q2. Now, take a look below the median. I have this, and above the median, I have that. Now, I go to this blue region. I don't count the Q2. I don't count the 41. What's the middle here? 36. So 36 is Q1. What's the middle in the other one? 41. That's Q3. Okay. 49. What did I say?
41.
Oh, sorry. 49. Okay. So now I have Q1, Q2, Q3. Okay. This number is the min. This number is the max. Okay. So, and then where is the median here? Which one of these numbers is the median? Q2. Okay, so I say min is 25. Q1, 36. Q2, 41. Q3, 49. Max, 54. Okay, that's the 5-number summary. Okay, you can't just give me 25, 36, 41. You have to label them, okay? And you know, I mean, it's nice to have some sort of order. I think this is a good order to go. Yeah. No. Yeah, labeling them here is not enough. You have to like list them later, okay? All right, so here we go. The number of boxes of donuts Josh sold for a fundraiser each day for the last 11 days were this. Find the 5-number summary and interpret the meaning. Okay, so, okay, we need to sort this data, right? So we start with 14, that's the smallest one. And then I have a 16, 2 17s, 21. Oh, we have a 20 and then a 21, thank you. And then a 22, 26, and 35, okay. And then you have to count, right? It's supposed to be 11, 10, 11, okay? So again, where's Q1? I'm sorry, where's Q2? 21. Okay, so where's, huh? Oh, Q2, I'm sorry. So where's Q1? 17. And Q3? 28. And then we have min and max, right? So let's write down the summary. Min, 14. Q1, 17. Q2, 21. Q3, 28. Max, 35.
And you have to structure it like that or label it like min, Q1, Q2, Q3,
Right.
max.
Okay? Yep. Okay. Okay. So now we talked about two different things, right? We talked about mean, median, mode, and then we talked about range and 5-number summary. We usually use one of these two methods to describe data, okay? So it's either mean, median, mode or 5-number summary. And the way in which we decide which method to use to describe the data has to do with outliers. So what are outliers? Exactly. Right. So for example, like if somebody, like if the entire class, you know, scored between, you know, I don't know, like 80 to 100, and then one person got, let's say, a 50 because they didn't see like the second half of the test, that 50 is the outlier. Okay? Yeah.
An outlier has to do with like the spread, like the spread of the data set, one that's been thought off from like the average.
Right. And I'm going to show you guys right now exactly how to figure out what is an outlier, right? Because it can't be like, oh, this one looks like it's too far off. No, it has to be a way. So an outlier is an extremely high or an extremely low value when compared with the rest of the values. To check, we need to look for data values that are beyond the upper or lower quartiles by more than 1.5 times the interquartile range. Okay, all this seems like it's just words for somebody to impress their friends, right? But let's just dig in and see what we're talking about. This interquartile range, you know, that's conveniently labeled IQR, is basically Q3 minus Q1, okay? Q3 minus Q1. An outlier would be identified if one or more of the following things happened. So either your specific value is less than Q1 minus 1.5 IQR, or the value is greater than Q3 plus 1.5 IQR. All right? So let's take a look and see if there are any outliers here. Okay, so let's sort this data. It's 45, 71, 79, 82, 88, 88, 90, 94. How many total? 8, right? Okay, so so this is the bottom half. This is the upper half. Median, or Q2, is going to come here. And if there is no specific value there, then you have to take the average of 82 and 88, which is 85. Okay? So 85. Now, for Q1, we have the same situation here. Okay? It's going to fall in between here. So what's the middle value there? 75. So Q1 is 75. And what's Q3? 89. So basically what we're doing is 88 plus 90 divided by 2, or the middle number. Okay, now let's find what IQR is. IQR is just 89 minus 75. And that's equal to 14. Okay, the next thing you want to calculate is 1.5 times 14, 21. Okay? Okay, so now you want to know if the values on the outside, so is this first value less than Q1 minus this number? What's Q1 minus that number? Minus 21. This is 75 minus 21. How much is that? 54. Since 45 is less than 54, it's an outlier. Okay? What about the 94? Is that an outlier?
Yeah.
So how would we do that? How would we figure that out? 94, Q3,
21.
Q3 plus 21. Okay, so 89 plus 21 is how much? Like 110, right? Is 94 greater than 110? No, so it's not an outlier. Okay, so that's the only outlier. Okay, so let's go here. Find the median and mean of the data set with and without the outlier. So with the outlier, this is, 45 plus 71, 79, 82, 88, 88, 90, 94, all divided by 2. And the median is 79.63. I'm sorry, the mean. I don't know why it's divided by 2. What should I divide by? 8. 11 was the previous one. Okay? Okay, without the outlier, it's just 71 plus 79, 82, 88, 88, 90, 94 divided by 7 this time, 84.57. Okay, so you see how there is a difference there. Okay? Yeah. Good question. What's the median for with outlier? 85. Okay, with the outlier, the median is 85. Now, if I were to take out this one, what would be the median? 88. It would be the center one there. Okay? Okay. Okay. So let's take so here's another question for you guys. So with and without outlier, the median goes from 79 to 84. Okay? That's a difference of how many? About 5. Okay? What about the median? How much does that change?
3.
About 3. So which of these is affected more by the outlier?
The mean.
The mean. Okay? So mean affected more by outlier. Okay, next one. Okay, so the number of text messages Tommy received. Here we go. Lots of text for Tommy. Okay, this one's important that we, let's sort it from highest to lowest. So we have a 10, 2 11s, a 14, 3 15s, a 16, 17, 18, 19, 20, 21, 4 24s, oh no, 3 24s, 1 28, and a 40.
There's 3 15s.
Yeah. So how many are there? 1 2 3, 1 2 3 4 5 6, 18 total. 18 total. Okay? Now, so let's talk about an outlier. So Q2 would be in the middle of 17 and 18. So how much would Q2 be? Good. How much would Q3 be? Or Q1. Let's go with Q1 first. So this is what we're taking. 15. Q1 is 15. And then what about Q3? 24, yeah. Because like the repetitions happen right when, you're going to take the average, so it's easy. Okay, so IQR, you subtract Q3 minus Q1, so 24 minus 15. Okay, that's 9. 1.5 times 9 is 13.5. Okay, now here's a quick way to do this. Take Q1 minus 13.5. So here's Q1. If you go 13.5 over this way, what is that? 1.5. So 15 minus 13.5, 1.5. Take Q3 and add 13.5. Where do we go? That's 24 plus 13.5, 37.5. So now you want to see if there are any numbers smaller than 1.5 or higher than 37.5, and that means which one is an outlier?
40.
The 40. Huh?
It asks for the mean. I don't know how this is.
Well, with your calculators. Okay, so yeah, we're not going to write it all out. It's too much to write out. Okay? But, I mean, you guys know how to find the mean, right? So you get 19 here. And what's the median? For the first one? 17.5. Okay. For the other one, you get 17.8. And tell me what the median would be. If we take this out, I'm sorry, if we take this 40 out, it would be 17. So again, you see how the median only shifts by 0.5, but the mean shifts by more, okay? And it doesn't have to be like exorbitantly more. The fact is that every single time the outlier will affect the mean more, okay? Okay, so that's this lesson, and I have a handout for you guys for homework.